We are going to continue in chapter 3. And today we are going to cover section 3.2, which is going to talk about compound interest. So in 3.1, we just talked about simple interest. Now we're going to talk about compound interest. When we talk about compound interest, the interest that is earned is then called a reinvested interest. So when you put money in a bank and you have a savings account, the interest that is there is compound interest. So at the end of the month, what can happen is you can earn a few cents. It's generally not a whole lot, maybe $1 or $2, depending on how much you have in the account. And that interest is then added to your account. And then the next month, the interest you earn is based off of the money you have plus the interest that you earned. So that interest is being reinvested. It's being compounded on top of the previous interest that you've earned. The formula we have is shown here as A equals P times the quantity 1 plus R over M to the MT power. A and P are the same as they were last week. A is the future value. P is the principal or the initial money that you put in and just let sit. R is still the rate in decimal form. T is still the time in terms of years, but we have now added this other variable M. And our book uses M, some other books use N. It just depends on what text you're using. But the concept is this variable stands for how many times in the year you get your interest. Generally, banks, like I said, do it like once a month. You'll see it on your statement. At the end of the month, you earn so much extra that goes into your account. We have options, though. It could be semi-annually, which means 2. Quarterly means 4 times a year. Monthly means 12 times a year. Weekly would be 52 times a year. Daily, 365 times a year. So M is just the number of compounded periods in the year. So basically what we're doing is we're taking the annual interest rate and then dividing that amongst how many months or quarters or how many times we're getting that interest, and then calculating our future value based on that. We will start with the easiest ones of just trying to find our future value. It says if $100 is invested at 6% compounded, we're going to do 3 options: annually, quarterly, and monthly. What is the amount that you're going to have after 4 years? And then how much interest did you earn? So option 1 is going to be annually. So I am solving all of these for A, but I'm going to change the M, or the amount of times I get interest in the year. So $100 is invested, 1 plus, my interest rate is 6%, so it's going to be 0.06. If it's annually, it's 1 time a year. So I could put divide by 1, or I could just leave it as the simple interest, the 1 plus 0.06. And then in this case, we are going to compound it so we have an exponent. The exponent is what you divided by 1 times the number of years, 4. 1 times 4 is 4. And then all you need to do is open any scientific calculator, be it your TI, if you have it on your phone, if you want to use Desmos. You're going to type this in exactly as you see it, parentheses included. Make sure you have the exponent in the right spot, that is an exponent, not that you're multiplying. You should end up with $126.25. Which means if you only put $100 in the account and let it sit, you gained $26.25 in interest. For quarterly, it's going to look similar, except for we're now going to divide our annual interest rate of 6% by 4. So that interest of 6% per year is going to turn into 1.5% 4 times a year. 1.5, 4 times a year totals 6%. Now, our power is going to be what we divided by 4 times 4. So your power is how many times total you got that interest. 4 times a year for 4 years is 16 times. So usually what I will do is I will do that math before I go and put this into my calculator, just so I have a single exponent of 16. And then you'll go to your scientific calculator, you'll type that in. I get $126.90. So I earned a little bit more money, $26.90 instead of $26.25. For C, monthly, I will now take my interest rate and divide by 12 because there are 12 months in a year. So I earn interest 12 times a year for 4 years for a total of 48 times. So my exponent is 48. Again, go to your scientific calculator. This one's going to be 127.05, which means the interest I earned was $27.05. What that means, the more frequently you compound your interest, the more money you will earn. Granted, we only did this with $100. So in the end, there was only, 80 cents difference from the first to the last. But if you have a lot more money invested in this account, that interest is going to pile up even faster. The next one we're going to do is going to work backwards. It says an investment company pays 8% compounded quarterly. How much should you deposit now to have $6,000 3 years from now or 6 years from now? So this is the future value, or the A. I want to have $6,000. So I need to determine what I need to put in now to be able to reach that value. So for A, 6,000 is our goal. We are trying to find the P. 1 plus 8% is 0.08. Quarterly means I'm going to divide that by 4. So then I'm going to raise it to the 4 times 3 years. So 4 times 3 is a power of 12. 4 times a year for 3 years, 12 times I'm going to earn that interest. Now, you can do this in 2 steps if you want. You could calculate this part out here, but you're going to round it, and then you can divide. Or you can just use your scientific calculator here. So option 1, like I said, is you could do this part here, 1 plus 0.08 over 4, close parentheses, raise it to the 12th power. What I'm going to get, though, is a rounded decimal. So if I do that and I take 6,000, have an extra 0 in there, divided by that rounded value, let's say I just did 3 decimal places, 1.268, this would be my answer. If you want to be as accurate as possible, we know to get P by itself, I have to get rid of this entire parentheses piece, so I could just divide out that whole piece. This will give me the most accurate answer. Again, when we talked last class, I did say that there is always going to be buffer room in these problems. They allow for this leeway just in how you round. But like I said, I want to have the most accurate answer, so I'm going to use this. And I did. I added another 0 again. 6,000. There we go. So when I rounded it, I ended up with $4,731.86. When I didn't round, I had $4,730.96. So in the end, was I off by like $1? Okay, that's because I rounded. Will it work in the answer? Yes, it'll be fine. It's not going to mark you wrong for being off because you chose to do this part, rounded it, and then divide it. There will be, like I said, a margin of error on both sides, slightly up or down, depending on how you round it. All right, so that means if I chose this first option, I would have to invest $4,730.96 today to reach that goal in 3 years. If I have 6 years of time, I don't need to invest as much today. So we could find that. 6,000 equals P 1 plus. The only thing that's changing is my exponent. I'm still compounding my 8% quarterly, but now I'm getting that quarterly 6 years. So 24 times I'm getting my interest. Which means all I need to do is go up here and I could change my exponent to 24. And now all I need is $3,730.33 today to get me to that goal. 37, 30, 33, 37, 30, 33. So we've solved for A, we've solved for P. There are other variables that we can also solve for. This one asks us to find the rate that makes $10,000 reach $27,000 in 10 years if it is compounded annually. All right, so I invest 10,000, that's my P. 27,000 is my A. T is 10. So 27,000 equals 10,000. 1 plus, I don't know R. Compounded annually means I would just divide by 1. So I'm just going to leave it as R raised to the 10th power. First thing in solving this would be to divide by 10,000. So I will get 2.7 equals 1 plus R to the 10th power. How do I get rid of that exponent of 10? I undo a power with a what? If this was like x squared equals 49, how would you undo the power 2? We don't remember? Roots? Right? Like if I had x squared equals 49 and I square root, the answer would be positive or negative 7, right? Because 7 times itself makes 49. So if I have a power and I need to undo it, I use that root. So I'm going to use the 10th root to undo the 10th power. So I'm going to use this guy here, the nth root. So the 10th root of 2.7 gives me 1, sorry, that's 2.7, 1.1044. You can see it all here. I will round as much as I can over here. 1 0.1044 equals 1 plus r. Then if I want to get r by itself, I would just subtract 1. That leaves me with r equals 0.1044. Again, this is rounded. Had I typed the whole value, it may be slightly different. That is, if I times by 100, times by 100, 10.44% is the rate. So if this was to the 24th power, you would take the 24th root to undo that power. Now comes the most difficult one when you are asked to find t. How long, t, will it take 4,000 to grow to 9,000 if it is invested at 7% compounded monthly? So P is 4,000, A is 9,000, my R is 7%, monthly is 12. All right, that means 9,000 equals 4,000, open parentheses, 1 plus 7% is 0.07 divided by 12 is raised to the 12t. I do not know what time is. So the first step in solving this is to divide out that 4,000. If I take 9,000 and divide by 4,000, I'm left with 2.25 equals 1 plus 0.07 over 12 to the 12t. Now, the power is not just a number, it has a variable in it. The first thing I'm going to do is I'm going to simplify what's inside here. So I would do 1 plus 0.07 over 12. And again, I'm going to round it to the best of my ability. 1.0058 to the 12t. When you have a variable in the exponent, the only way to undo that is with logs. Now your option is natural log, regular log, doesn't matter. Generally, I default to natural log. So what I have to do here is I'm going to natural log both sides. There is a property for logs that says if you take the log of anything to a power, so like this, if you take the log of anything to a power, you can rewrite this as the power times log of the number. That's a property. So to get this power to come down, if I natural log both sides, I now have the natural log of 2.25 equals 12t times the natural log of 1.0058. And now I've made this, okay, it's multiplication. I can undo multiplication by division. So I will then divide both sides by that natural log of 1.0058. I'm not going to round anything yet at this point. I'll type it all in my calculator when I'm done here. So natural log of 2.25 divided by the natural log of 1.0058 equals 12t, which means that if we want to find t, then I'm going to take this answer and divide it by 12. All right, so then I'm going to get my calculator to do the math. If you are using the Desmos calculator, you can type ln and it'll pop up, or you can go to your function here and it's over here. So natural log or base 10 log, it doesn't matter which one you use, we're going to get the same answer. So like I said, I always default to natural log. It's just what I do. 2.25 divided by the natural log 1.0058. And I'm going to take that answer, 140.2206288, and divide it by 12. I'm going to round this final answer to 1 decimal point. So 11.7 is going to be my T, which means about 11.7 years is what I am going to need. I'm also going to show you a tool that will help you do these. Now I have two choices. Do you want me to redo these problems with that tool, or would you like me to show you new examples with the tool? I'm hearing new ones. Yes, okay. In our Blackboard, under this week, which is week 13, it says Desmos Compound Interest Calculator. And it opens up this lovely thing here. And you can see that it solves for all of the variables that we talked about. Now, their variables are different than what we wrote, okay? Future value they have is F, we have A. P is present value, that's what we have. Their interest rate is I, which stands for the R over the M. And their number of periods is our M times T. So the key is, if you're using this, the I is our R over M, and their N is our MT. That's important, especially for the first problems here. All right, our first one says, a newborn child receives a $20,000 gift towards college from her grandparents. How much will the $20,000 be worth in 17 years if it's invested at 7% compounded quarterly? So you can see how this calculator is called compound interest. Our goal is to solve for the future value. So if I want to know how much I have in the future, I can open this one here. You need to enter these three things. P is the initial investment of $20,000. Your interest rate is your R divided by your M. So our interest rate is 7%, but it has to be compounded quarterly. So I'm going to divide that by 4. And then our N is our M times our T. So 4 times a year times 17 years. I actually can just type that. I can do 4 times 17. I don't have to actually do the math. It'll do the math for me. It's 68. And then you'll see where they plug it in. So the 20,000 is here. 1 plus 0.07 over 4 to the 68th power. So the nice thing about this is that when you're doing them, it will not round along the way, and it will give you the most accurate answer. So your $20,000 at your birth turns into $65,000 and $65,068.44. 65,068. Okay, let's read the next one. It says, in a suburb, housing costs have been increasing at 5.2% per year annually, compounded annually, for the past 8 years. A house worth $260,000 now would have been worth what value 8 years ago? So I'm working backwards. This is the current. I want to go back in time. So I'm trying to find the P, what I started with. We have 260 $23,000. Interest rate is 5.2, so 0.052. It's annually, so I don't have to actually divide by anything. And then I don't have to multiply by, or multiplying by 1 doesn't change the answer, so it's just 8. But if you were compounding, let's say monthly or whatever, you would divide this by that value and multiply n by that value. It will give us our answer here. 173,319.50. 173,319. So the house price rose $87,000, roughly. Okay, read the next one. It says you've saved $7,000 towards the purchase of a car costing $9,000. How long will the $7,000 have to invest at 9% compounded monthly to grow to that $9,000? So it's asking for the time. So I'm going to open up this one here. So I presently have 7,000. My future goal, 9,000. I am earning 9%, so 0.09 divided by 12. This right here says 33.6. It says round up to the next higher month, if not exact. So we would round that up to 34. And whatever your compound period is, that's what this answer is. So if you are calculating this monthly, your answer comes out as monthly. This is 34 months. If you were calculating this yearly, this answer would be years. If you calculate it quarterly, it would be that many quarters. Okay? So rounded up, 34 months. All right, there's one other way that we can compound interest. That is called continuously compounded interest. And the formula for this is A equals P, E to the RT. If $8,000 is invested at 7% compounded continuously, so here's the key. When you're reading these, you're going to see the word compounded continuously, not quarterly or monthly. That's going to be your key to use this formula. What's the amount after 6 years? I have 8,000 times E. E is just a number. R is 0.07. And then T is 6. So all I need to do is go to my basic scientific one here, 8,000. So you can then see under the function, it's this guy, e to the x. So e to the, and then I always put it in parentheses because I have to make sure I keep both pieces in the power, 0.07 times 6. If I don't do that, it's going to put the 0.07 up top and then may put the times 6 down bottom, and then that's not going to give me the same answer. All right, so I will have $12,175.69. $23,000 is invested. So 23,000 is what I invest at 13.5% compounded continuously. So that's my PERT equation. So e to the, let's see, 13.5 is 0.135. And then how much is going to be there after 15 years? So then I'll just raise that to the 0.135 times 15. This guy, there is no Desmos calculator for this one, just so you know. 23,000 e to the 0.135 times 15. My $23,000 turned into $174,000. $174,000 15 years later. So 174,250, and it was 55 cents. We can also solve for R or for T. So we'll do those guys here. If an investment earns $9,000 compounding continuously, how much should you deposit now to have $25,000 36 months from now or 9 years from now? Key is every time we do these problems, it's in terms of years. So 36 months is 3 years. So always make sure when you're using this one, it's in terms of years and nothing else. All right, we want to have 25,000. We don't know P, oops. So then I just have E to the, okay, 9%, 0.09 times 3. To get P by itself, I just have to divide by that E to the 0.09 times 3 power. 25,000, I want to divide that by E to the 0.09 times 3 power. And I added an extra 0 again. So I would need to deposit today $19,084.49. If I only had 3 years to reach that goal. For B, I now have 9 years. So I'm changing the T, so E to the 0.09 times 9. So all I'm going to do then is change, I'm going to divide by E to the 0.09 times 9 power. So I can go back here and I can just change this guy to a 9. And if I have 9 years, I would only need to put down $11,121.45 today. $0.45. I knew it was 40 something. 45. Last variable we can solve for could be R or T. What rate causes $5,000 to turn into $12,000 if it's compounded continuously for 13 years? So here's my P, here's my A. 12,000 equals 5,000. E, I don't know R, and it's going to be times 13. Now, here's why I default to the natural log. Reason being is the E exponential is only undone with the natural log. So to make it easy, I just say always use natural log if you are solving these by hand to make sure that it'll always work. First step is going to be to divide out that 5,000. So if I take 12,000 and divide by 5,000, I get 2.4 is going to equal E to the 13R. I'm just going to rewrite that order. I like having the number in front of my variable. Now, to undo an exponent in a power, natural log both sides. So natural log of 2.4 equals the natural log of E to the 13R. Why did we do that? Well, we said because there's a property that if your log has an exponent, that value can come down front as multiplication. So this can then be the natural log of 2.4 equals 13R times the natural log of E. Okay, so this is the property that a power in a log can come down as multiplication. Now, quick little thing to note, again, why I use the natural log here is because if I take the natural log of e, it's 1. It cancels out the e. That's why I use the natural log. So this piece is actually just gone. It's a 1. If I times by 1, it doesn't change my answer, so I don't even need to write it anymore. So then to get r by itself, all I have to do is divide by 13. So I'll take the natural log of 2.4 and divide by 13. Natural log of 2.4. I'm going to put parentheses around that and then divide by, I said 13. So 0.067 around that. Because generally I like to keep my interest rate to 1 decimal point, 6.7%. Do one more. Solving for t. How long will it take 6,000 to grow to 8,600 if it's invested at 9.6% compounded continuously? So 8,600 equals 6,000 E, 9.6, so 0.096 T. I'm going to first divide out the 6,000. Now, this one does not come out nicely, so I'm just going to round it here. It's 1.433 rounded equals E to the 0.096 T. So we said in order to get rid of the exponential on an E, we're going to log both sides. So natural log of 1.433 equals natural log of E to the 0.096 T. And then we said there's the property that can bring this power down front. And then we know that the natural log of E is just 1, so we can drop that out of our problem. Natural log 1.433 equals 0.096 T. So then all I have to do to find T is divide by 0.096. So natural log of 1.433 divide by 0.096. And this is going to be in terms of years. So about 3.75 years. We okay with these guys? All right, I have one more concept I'm going to do. I did have extra examples. If we need to go back and look, we can do that. The last concept here is called APY versus APR. What we have is when you go to a bank, they give you the APR, the annual percentage rate. And that is what we are plugging into all of our formulas. When they say you're earning 2% and then compounded quarterly, that 2% is their APR. What happens when you compound interest, though, we've shown that you earn interest on interest. So what happens is in the term of a year, you actually earn slightly more than what is the APR. So what we can do is calculate what's called the APY to determine the actual interest that I earned compared to what the APR was. So it just depends on, am I doing a periodic one, quarterly, weekly, monthly, semi-annually, or am I doing it continuously? And then you're going to pick the corresponding formula. Okay. So it says, what is the annual percentage yield, or APY, for money invested at an annual rate of 2.9% compounded monthly? So that's going to be the first equation. APY equals 1 plus R over M to the M, and then subtract 1. So I'm just going to plug in what I got here. 1 plus rate 0.039 divided by 12 is going to be raised to the 12th, and then I'm going to subtract 1. So the bank advertises you're going to earn 3.9%. 1 plus 0.039 over 12. Raise it to the, do I have a, okay, oh, there it is. Raise it to the 12th power. And then I arrow out, so I'm no longer in the exponent, minus 1. And I get 0.0397. Or almost 4% interest if I were to round that. So I am earning just a little bit more than 3.9% over the course of the year. We can find the APY for 2.3% compounded quarterly. 1 plus 0.023 is going to be divided by 4, raised to the 4th power minus 1. Raise that to the 4th power, arrow out, minus 1. Okay, not a whole lot difference, but 0.0232. Or 2.32%. I'm going to skip this quarterly one here since we've already done one. We can just do the continuous equation. All right, what is the annual percentage yield invested for 2.95 continuous? So this one is e to the r minus 1. So e to the 0.0295 minus 1. Again, I'm just dividing my rate by 100. That is how I'm getting my value that I put in my formula here. E to the 0.0295, arrow out, minus 1. 0.299. So I actually earned 2.99% over the course of the year. All right, what I'm going to have you do is the following. Determine how much money you would like to put into any savings account. This is all hypothetical, okay? But you are going to do a Google search for a local bank to where you live for their current savings account interest rate. So you're going to list what bank you chose and their interest rate. So now we're up to 3 points. Next point, how long are you going to let your money sit in that account? Calculate 1, the amount of money you will have earning simple interest, and I give you the formula. Calculate the amount of money you will have earning compound interest monthly. Again, I give you the formula. Calculate the amount of money you will have in the account compounded continuously. So you're calculating simple interest, compound monthly, compound continuously. Next question, which option is always going to be the best if you have the option to choose? And then lastly, for your compound values, monthly and continuously, calculate the corresponding APY. And then this isn't due until the 26th, which I think is, what is that, Sunday? So you have some time to work on this one, but I wanted you just to kind of practice seeing the different options, looking up the best rates you can find, and practicing. Okay? Sorry, I know today was a lot longer than normal. This is, again, why I said I usually like to save this to the end, just because it's a little more heavy. So if you have any questions, let me know.